Hello everybody, my name is Peter Klappa from the School of Biosciences, and in this screencast I want to discuss with you the maths of first order kinetics. So let's assume we have a reaction where we have the reactant A and that reacts in a first order reaction. So we can write for the rate dA over dt equals minus K times the concentration of A to the power of 1, because it is a first order reaction. And we've got the minus here because A is a reactant and disappears. Now with this equation we can't do a lot because it is a differential equation. So we have to, what is generally called, separate the variables. And that means we have, on one side we have dA, and on the other side we have the function of dt. So the way we do that is basically simple maths. So we bring everything with dt to that side, and everything with A we bring it to that side. So what we get is dA over the concentration of A, don't write to the power of 1, equals minus K times dt. So we've got our variables separated. Now we can do the reverse operation of the differentiation, and the reverse operation of differentiation is integration. So I indicate it like that. So we integrate both sides of this equation. Now we can write the right-hand side of this equation in a slightly different form. We can write it as minus K times integral of dt. The left-hand side of the equation we can't do a lot, so it stands as integral of dA over A. Now we can solve this two integrals. We know that the function for this, when we look it up in our integral tables, we get ln A final minus ln A initial equals minus K times the integral of this, and this would be T final minus T initial. And I can write this a little bit neater. I can use the laws of logarithm here, and I can write ln A final over A initial equals minus K times T final minus T initial. Or if I don't want the ln here, I can take both sides E, and I'll indicate it like that, E. So I would get E to the power of ln A final minus over A initial equals E to the power of minus K times T final minus T initial. And we know that E and ln cancels out, so I get A final, so the concentration, the final concentration of A divided by the concentration of the starting concentration of A equals E to the power of minus K times T final minus T initial. But in reality, all these equations here are exactly the same, and they come from this solving these integrals.